Alright, so we've seen direct variation. In this next example, we're going to see direct variation as an nth power. So in the last one, it was linear, like slope-intercept, y equals mx. This one, we can have either a squared or a cubed. Y equals, oh, why are you not coming up quickly? Y equals kx to the n for some constant k. I'm going to pause the video and try to refresh my screen. It's lagging a little. And are we back? Hey, there we go. Good. Alright, so let's take a look at how this works. The distance a ball rolls down an inclined plane is directly proportional to the square. So we know right away that we're not talking about x, we're talking about x squared of the time it rolls. During the first second, it rolls 8 feet. Write an equation relating the distance traveled for the time. So we've got our formula, direct variation, y equals kx. And in this case, since it's proportional to the square, we're going to do that. Now let's take a look at what variable matches with what. The distance is directly proportional. So y is d. Right? The first thing you see is the isolated variable. To the square of the time it rolls. Square of time. Time squared. So there we go. We've got our equation. Now we just need to find out what k equals. So during the first second, so if t is 1, it rolled 8 feet. 1 squared is 1, so k equals 8. And so our equation is y equals 8x squared. And so if we go ahead and check this, let's see how far the ball will roll during the first 3 seconds. We should be using d and t. 8t squared is our formula. Let's go ahead and plug in 3 for t. 3 squared is 9. 8 times 9 is 72. If we let that ball roll for 3 seconds, it's going to end up down here at 72 feet. Let's see if you can do it for problem 75. Alright, 75. A stream with a velocity of 1/4 mile per hour can move coarse sand particles about 0.2 inches in diameter. Approximate the velocity required to carry particles 0.12 in diameter. Up at the top it says in exercises 75 and 76, use the fact that the diameter of the largest particle can be moved by a stream varies approximately directly as the square of the velocity. So diameter varies directly, put in the k, with the square of velocity. So we have those two things. So let's go ahead and check this. They said velocity is 1/4 squared, and the diameter is 0.02. So let's solve for k. 1 times 1 is 1. 4 times 4 is 16. We need to divide both sides by 1/16 or times both sides by 16. 16 times 0.02 is 0.32. So that's our k. And so we can rewrite this as d equals 0.32 v squared. And so our last step is to find the velocity for a particle that's 0.12 inches in diameter. So let's plug in 0.12 equals 0.32 v squared. We'll isolate v. If I can do algebra correctly, divide by 0.32. And what do we got here? 0.12 divided by 0.32 is 0.375. Equals v squared. Let's go ahead and square root both sides. Come on back, calculator. There you are. And 0.375 to the Square root, remember square roots are the 1/2 radical, 0.375 to the 1/2, and we get 0.61 as our final answer for V. Was it 0.62? Did I round right? Nope, 0.61. So 0.61 equals V.